last note set, so it's going to kind of bring things full circle. We'll be practicing quite a few things, kind of mixed practice, so we might do one problem by factoring, and then we'll have to do the next problem by quadratic formula, and then the next problem will be a word problem. But it's mixed practice. We got to get through number 8 today. How can we solve a quadratic? Give me all the methods. Quadratic formula, that was learned yesterday. I'm going to put these in order of the way that we learned them. So number 5, quadratic formula. Remember, the pro of quadratic formula is that it always works. The con is that it can be messy. What else did we learn? What other methods do we have? Factoring. Let's do number 2, factoring. If you factor it, first step is to get it equal to 0, and then use what? Zero product property. Completing the square, that was after factoring, right? Completing the square. Completing the square, you get it into vertex form and then solve by square roots. That's actually number 4 as well. You don't always have to complete the square to solve by square roots. Sometimes it's already in vertex form and you can solve by square roots. Sometimes that's called extracting the square. Same thing. Solve by square roots. And what's number 1? Graphing. Remember, graphing is nice if it works out. Half the time it won't work out. Factoring is nice, again, when it works out. Most of the time it won't work out. Completing the square always works, but it can get really messy really fast, right? And then solve by square roots sometimes is nice, but again, it always works, but sometimes it can get really messy really fast. So let's solve number 1. How do you want to solve number 1? Bless you. Add 27. Why are we going to add 27? To make it equal to 0. What's the point of getting it equal to 0? So you can factor it. Okay, okay, let's add 27. So 3x squared plus 27 equals 0. And then I heard somebody say GCF, right? What's your GCF? 3. What does that leave you with? X squared plus 9. What's the issue? Can't factor that. It's not a difference of squares, it's a sum of squares, and we can't factor a sum of squares. And so it's not factorable, so we should go back to the drawing board and do what? So this didn't work out. Let's go over here. We'll rewrite the problem. 3x squared equals negative 27. Factoring didn't work out. What could I do from here? It's already in vertex form, isn't it? Yeah, divide by 3. You could do quadratic formula if you wanted to. I'm going to divide by 3. That'll get me x squared is equal to, what? Negative 9. And then how could I solve for x? Square root. This is the method called extracting the square or solving by square root. I'm going to put the method in this like magenta color, solving by square roots, so that if you had any questions about what method we solved by, you could look back and see what method we wrote down. You don't have to tell me the method you're choosing, but I'm going to go ahead and label them so we see which one looks, or what they look like. What's the square root of x squared? It's what? It's what? It's what? It's what? Absolute value of x. I know I'm deaf, but I'm not that deaf. What's the square root of negative 9? 3i. Good. And what are you ready for once you have the absolute value of x? The piecewise? Got a question in B block today that said, hey, what if I forget the piecewise? Then you're going to lose points. It's built into the question of like, when you have the absolute value, we expect to see a piecewise definition. If you don't give me that piecewise definition, you're going to lose points. So here we've got x and then negative x. I don't even really need those parentheses there. And do I have any transformations? No. So what's my domain? X is greater than or equal to 0, and x is less than 0. Good. So then I'll take my first piecewise, which was x is greater than or equal to 0. That'll be positive x is equal to 3i, and that one's already done. And then my other one was x is less than 0. For that one, I have negative x is equal to 3i. Divide by negative 1, and I get x is equal to negative 3i. And that one's done. It did say solve And so we're good just, or find the solution, so we're good just putting x equals. Anytime it says solutions or roots, you're good with just x equals. If it says x-intercepts or zeros, I expect to see the ordered pair. And if I don't, then you'll lose points. Questions on number 1? Pretty okay? Are we ready for number 2? How do you want to solve number 2? Subtract 9. So 2x squared plus x minus 9 equals 0. What's your motive here? Complete the square? We could try to factor. What's something really fast that you could do to see if it's factorable? That you'd end up maybe having to do even if it's not factorable. Yes, a piece of the quadratic formula. The discriminant, let's run through that really quickly. The discriminant is b squared minus 4ac, and this will tell me if it's factorable or not. If it is, then I can keep going with factoring. If it's not, then I know to ditch that and go somewhere else. What is b? 1, so this would be 1 squared minus 4 times what's a? 2. And then times c, which is negative 9. 1 squared is 1. Negative 4 times 2 is negative 8. Then multiply that by negative 9. Positive 72. And what's 1 plus 72? 73. What do you know about 73? It's a prime number. What happens when you take the square root of 73? It's irrational. So is this factorable? No. So that tells me don't even try to factor it. I'm going to get the square root of 73, which is not rational. It's irrational. And so if it's not factorable, we won't be able to see it by graphing. So we can either complete the square and solve by square roots, or we can quadratic formula. Which way do you want to go? You want to complete the square? You go for it. Tell me why I'm not going to complete the square. You see how this x has a 1 in the front, and that's odd? You're already going to have to take a 2 out of that, which will make it 1/2. And then you're going to have to split 1/2, which will make it 1/4, and it's going to get really messy. I would go quadratic formula in this case. And you already have part of the quadratic formula done already. So let's go x equals, how does the quadratic formula start? Negative b, so negative times 1 over 2a, so 2 times 2. Then what? Plus or minus square root. Didn't we already do that? 73 over 2 times a, which is 2 times 2. So we got x equals negative times 1 is negative 1 over 2 times 2 is 4. Can we simplify the square root of 73? No, so square root of 73 over 2 times 2 is 4. What kind of number is negative 1/4? Rational. What kind of number is the square root of 73 over 4? Irrational. We cannot combine those, so this is where it stays. We can talk about it. Remind me later. No, they didn't. Let's see. Rocking and rolling. Oh. Let's look. Oh, you're flipping your paper. Good. All right. How do you want to do number 3? Do what? Can you divide 16 by 3? Nope. We can factor it, but there's no greatest common factor. You can't divide 16 by 3, so there's no greatest common factor, but we can try to factor it by trial and error. What multiplies to give you 3x squared? 3x and x. Notice that my factors are equal to 0 here. I will take points off if it's not equal to 0, so make sure it's still equal to 0 in this step. What factors of 12 do you want to try? 4 and 3 in that order? 4, 3, inside will get me 4x, outside will get me 9x. Will that give me 16? Nope. Why can I not flip them around? You'd have a greatest common factor of 3 if you flipped them around, so that can't happen. What do you want to try now? 6 and 2. Not in that order, right? 2 and 6. That would give me 2x and 18x. How do I get a negative 16? Negative 18 plus 2. So negative 6, positive 2. And then you can't stop here because all you've done is factor it. How do you finish it? 0 product property. So 3x plus 2 is equal to 0, and x minus 6 is equal to 0, and I will be quiet as you finish those. Notice this is asking you to find the zeros, so you should not stop at x equals. You should write them as ordered pairs. Negative 2/3, comma 0, and 6, comma 0. Good. Ready to move on? Scream if you're not. What's up with 4? Oh, that method was factoring. Sorry, I forgot to put my method down. Factoring. The other method was quadratic formula, right? I just want to make sure I put that on the notes just in case we need it. Alright, what's up with number 4? Do what? Do what? There's 3 binomials. What else? Hey, what are those binomials doing? Multiplying. So what have they already done for us? Factored it. So our method right here will automatically be factoring because it's equal to 0. Now, if it wasn't equal to 0, you'd have to multiply it back out and take it from the beginning because there's no such thing as any other number product property except for 0 product property. But it's equal to 0, so they already factored for us. Tell me the catch. There's a difference of perfect squares in the middle, so that can be factored again. So we'll keep the 2x plus 1. What does x squared minus 4 factor into? X plus 2, x minus 2, and then you've got x plus 3, and all of that equals 0. How many zeros will you have? 4 of them, and write them as ordered pairs. I'm going to give you a second to do 0 product property. Wait, what? Here, if you multiply 2x with x squared and x, you'll get 2x to the 4th, which is where that degree comes in. Sorry, I had to make a pit stop for a cough drop. Negative 1/2 0, negative 2 0, 2 0, negative 3 0. Yeah? Ready to... Is it the word problem next? Yeah! Word problem. This will be great. It'll be fine. Mrs. Tate is building a fence for her dog, Sully. She has 200 feet of fencing. That's important. And we'll use the side of her house for enclosing the yard. What is the maximum area? So they're asking, what is the maximum area Sully will have in his yard? And what will the length and width need to be in order to maximize the area? Let's draw a picture. What will my picture have in it? A house. I'm going to do the side of my house, or the side of Miss Tate's house, okay? What else? A fence. I'm using, or Miss Tate is using one side of her house as that side of the fence. Tell me the parts of that fence, or the parts of our diagram. What? Length. Let's make the long side length, okay? And width. What's the other side? Width. Do we have another length? Yeah, but not really, because we're not using fence up there, right? Okay, so W is equal to width. What's the units for width? Feet, okay. L is equal to length, and what's the units for length? Feet. Give me another variable we have in this problem that's not in our picture. Area, big A, is equal to area. And what's the units for area? Feet squared. Because you're multiplying feet by feet, and feet times feet is feet squared. Good. How do I find the area of this rectangle? So A equals length times width, okay? That's part B. But our equation has too many variables. So let's find another relationship and substitute. What have I not used yet? Ooh, the 200. And the 200 is my feet of fencing, right? What am I using my fencing for? The what? For the dog, yep. Tell me in my diagram, where's my fencing gonna go? W, L, and W. Add those together, what do you get? 2W plus L. Okay? If we can solve this for a variable, this kind of goes back to systems in Unit 1. If you can solve this for a variable, then we can substitute back into our area equation. Which variable do you want to get by itself? L. Yeah, let's get L by itself. How do you get L by itself? Do what? Nope. Just subtract 2W. So we'll get 200 minus 2W equals L. Notice if you solved for W, you'd have to end up dividing by 2, and then you'd have 1/2 L, and that'd be weird. So this is pretty good. If L is equal to 200 minus 2W, then that can go in for L in this equation. So that's going to go in there. So now we're going to have area is equal to my length is 200 minus 2W times my width of W. That's my new equation. Now I have one variable and I can work with that. Okay. What do we know about this? What kind of equation are we looking at? It's one binomial and just times W, right? What are we going to get when we multiply W? We're going to get W squared, so this is a quadratic, right? Okay, let's sketch a graph. So, sketch a graph. It's a quadratic. So that means it has to be a U shape. Which way is it opening? How do you know? What would be in front of W squared? It'd be what? So here you get 200 times W to be 200W, right? What do you get here? Negative 2W squared, so this would be negative 2W squared plus 200W, right? Which way does that open? Down. So it opens down. Do you know our y-intercept? What would happen if you plugged in 0 for your width? Yeah, it'd be 0, right? So we know that we cross at 0, 0. Is there a way that we could get the other x-intercept so that we can sketch our picture? So we know that it's a parabola opening downward. Is there a way that we could get this other x-intercept? What form is this? Factored form, right? Couldn't we just set that equal to 0? If we do 200 minus 2W times W equals 0, couldn't we find the roots? For this one, we'd have 200 minus 2W is equal to 0. How do you solve for W? Subtract 200. So you get negative 2W is equal to negative 200. Divide by negative 2, and what do I get? 100. So that tells me that I crossed the x-axis at 100, 0, along with this 0, 0 that we found over here. Notice that 0, 0 would come from that W that's on the end. When we set that equal to 0, we'd get W equals 0. Okay, cool. Tell me other things we know about our graph. It has a what? It does have a maximum. That would be at the tippy top, right? Do we know where that maximum happens? Don't you have the zeros? Or you could just look at your zeros, right? What's in the middle of your zeros? 50. So we know this would be 50, comma, how do we get the y value? We have an x, how do you get a y? Plug it in. So area equals, this is when x is equal to 50. That's what we're doing here. 200 minus 2 times 50 times 50. Yeah. What's 2 times 50? 100. And that's being multiplied by 50, right? And what's 200 minus 100? 100. And what's 100 times 50? Do what? 5,000. So we get capital A is equal to 5,000. That's the y value of our vertex because we plugged in the x value of 50 and got the y value to be 5,000. Isn't that our maximum? Yeah. So our max is at 50, 5,000. 50 is your input to your equation. What was the input to our equation? What took the place of our x variable? Variable. Letter. W. So our input is W, or what? What's W stand for? Width. So our width is what? 50 what? And then what's 5,000? It'd be the output to our equation, or what it's equal to. Right? A. Yep, so this is area. So max area is 5,000 feet squared. And what's the only thing I'm missing out of what they asked me for? The length. And what was the length? Notice you multiplied width and length together to get 5,000. So if you can backtrack to what you multiplied by 50 to get 5,000, you'll know the length. 100. That happened here. And that's our answer. What could you also do to find, what could you also do to find the maximum? Somebody mentioned it earlier. You could get it in vertex form by completing the square, right? So you could have completed the square as well. Flip it when you're ready. These aren't bad, I promise. This says find the x-intercepts, so those have to be ordered pairs as well. What are you going to do with number 6? First of all, if it says x-intercepts, what has to happen? Ordered pair and? Or ordered pair in which y equals 0. So first step to these equations should be 3x squared minus 2x minus 8 is equal to 0. And you want to see if it's factorable? What do you want to try for 8? What? No. I should have taken that off. 2 and 4? What about 4 and 2? 4 and 2? 4x and 6x. How do you get a negative 2x? Positive 4 minus 6, yeah. So positive 4 minus 2. And a positive times a negative is a negative in front of that 8, so that works out. I'll let you do zero product property real quick. No, I should have taken the quiz tomorrow. I should have taken that blue note of quiz tomorrow off the board because we're doing the quiz today. That's my fault. You do have a unit test on Friday. Make sure to write them as ordered pairs when you're finished. So I got -4/3, comma 0 for the first one. And 2, comma 0 for the second one. What questions do we have? What about 7? This one was by factoring. How should we solve the next one? Yeah, let's do solving by square roots. This is already in vertex form, so we can just go ahead and solve by square roots. Let's add the 3 first. So I get 1/2 times x plus 4 squared is equal to 3. And then what? Multiply by 2 to get rid of that 1/2. So I get x plus 4 squared is equal to 6. Square root both sides. If you multiplied all this back out, like if you expanded vertex form and then tried to factor it, tell me why it's not factorable. What kind of number is the square root of 6? Irrational, that's why it's not factorable. What's the square root of x plus 4 squared? Absolute value of x plus 4, and that equals, does the square root of 6 simplify? No. Now you're ready for piecewise? I've got x plus 4 for the first one, and negative times x plus 4 for the second one. And what does x plus 4 do to your graph? Left 4. So your domain will be x is greater than or equal to -4, and x is less than -4. For x is greater than or equal to -4, you'll have x plus 4, which comes from your piecewise, is equal to the square root of 6, which came from your absolute value equation. How do you solve that for x? Subtract 4. Notice, -4 is your rational number. That should come first. And then positive square root of 6 is your irrational number. That comes second. And then x is less than -4 will be negative times x plus 4 is equal to the square root of 6. The only extra step here is dividing by that -1 first. So you'll have x plus 4 is equal to negative square root of 6. And then same step as the last one, you're just going to subtract 4. -4 is your rational number. Negative square root of 6 is your irrational number. And I'm not boxing those. Tell me why. Has to be ordered pairs. You can actually just write one ordered pair. How would you do that? Aren't your x values both starting with -4 and then plus or minus the square root of 6, comma 0? That's a way you could get out of writing both your ordered pairs. You could just write one of them with a plus and a minus in there. I still need to see piecewise. I still need to see your solving steps for both of them. But you could get out of writing both ordered pairs by just writing one with the plus or the minus. What questions do we have? We are doing number 8. Tell me the good news about number 8. It says find the solution, so we can stop when we find x. But it says find the solution, so it should be equal to 0. So 2x squared plus 3x minus 2 is equal to 0. It is factorable. What do you multiply to get 2x squared? 2x and x. What do you multiply to get 2? 2 and 1. Tell me why the 2 does not go with the 2x. Because it would make a common factor, and we don't have a common factor in the original, so we shouldn't have a common factor inside one of our factors. So it should be 1 and then 2. This will give me 1x. This will give me 4x. How do I get a positive 3x? Plus 4 minus 1, so minus 1 plus 2. And then I'll let you do ZPP. There you go. Did you giggle? Somebody in my B block giggled, and that just ruined it for me. I have said that for years. And then someone giggled at it today, and I was like, really? Zero product property. It is math slang, I guess. I got negative, or 1/2 and -2, yeah? And that one was factoring. Yep. All right, we'll pick up on number 9 tomorrow. Make sure you go back and do that Math Excel homework from last night. That was 4.11. It's still open, even though it shows that it was due today. It's still open, so go back and do that. Show all your work on your homework paper. And then homework tonight is 4.12. We will go to the boards tomorrow, so make sure you do 4.12. And I'm probably going to pull from 4.10 as well. So make sure you have your homework done. You do have a unit test on Friday, so make sure you're staying on top of your homework to get the maximum results from your studying, from your review.